Hello, everybody. This is Mike here again. So I think I have a great topic to talk about today. AI, machine learning, uh, robotics, and making stuff autonomous or automation. So I'm going to let my guest speaker, talker, introduce himself, kind of give his background, because I think it's pretty cool. He's got a lot of experience in AI machine learning.
Okay, hey, thanks. Yeah, Maurice Tedder, and like you said, my main background is I'm a developer by occupation, and then my kind of hobby was like robotics and dabbling in AI. Um, so when I was in studying like computer science, my concentration was well, we called it intelligent systems back then. So back then it was like, what was that, like 2005 or four, something like that. Back then, you tell people like AI, artificial intelligence, intelligent systems. They're like, what is that? What do we need that for? And then we'll come like, 15, 20 years later, it's like all the rage. People want it and they don't even know why they want it. Like companies say, oh, we need AI, we need some kind of data science or something like that. But they don't even know why. They just like, it's the buzzword now. So yeah, I've been doing a lot with like in college. I was doing like the college robotics teams. It's called the Intelligent Ground Vehicle Competition. So I competed in that. It's basically like autonomous vehicle stuff before it really got like popular. So I think it's still going on, but I haven't participated in a while, in years. So that's how I got involved with like robotics things. And then I just like was doing some teaching, like STEM stuff with like Lego robotics for years through the local university here, Lawrence Tech University in Detroit. Or well, it's in Southfield, Michigan, but that's close to Detroit. So I did a lot of robotics STEM education with like Lego robots for a while. So that's mainly my background. And ever since then, I've been just doing kind of like my own hobbyists, like developing my own platforms, experimenting with things, using like the background is things I've learned and trying to learn new things. So
So, how did you? Because we can kind of talk about your classes. So you've been posting some classes online and AI and machine learning. So how did you get started? Well, doing classes, because I think you've done just more than just online stuff. You've done classes and you've been a teacher for computer science, AI, and robotics.
yeah, that got started. I think that was I think it's like a year and a half ago, like a couple summers ago. So how that started is, like I said, I was doing a lot of robotic stuff, like mainly like hardware and like integrating like software and hardware. So when I was on the robotics teams and things like that, uh, and then I guess I was hearing like all these buzzwords like machine learning, deep learning, and all that stuff. I'm like, what's going? Because I had not really like touch. I've been working with my hardware a lot, but not like doing the AI because it wasn't as popular back then. After I studied it and everything. So then I was learning all these things, and I started to look into it. I was like, okay, what is all this? Is this the same? And then it turns out it's the same thing I had studied in college. It's just things had advanced since I had learned the techniques and tools we were using. Because back then the only tools that were really available were like MATLAB, and then you had to use or create your own custom software, whatever language you were using back at the time. I think I was using Java back then. So then once I started learning it, like getting up to date on like the latest tools and technologies and things, I was thinking, well, there might be other people who are in the same situation. They may have like a programming background, and then they're here, they want to get involved with all this machine learning and AI technology. So after I kind of brushed up on it and started doing some of my own projects and getting back into it, that's when I developed the workshop. So that workshop was in person. It was like a 4-part workshop. We did it like, it was a 1-month workshop, but it was 4 Saturdays a month. So like I do like a workshop like every month. So, and it was like a Saturday for like 3 hours. So once I was getting it started, it was good, but over the summer, it was hard to get people to come out every Saturday for for a 3-hour workshop on a nice summer day. So that's when I said, well, I want to continue this. So let me just like create a video tutorial series of the actual live workshop I was doing. So I'm still in the process of that. I have a few more, but so far I'm up to, I think I'll be like publishing part 5 today. So it's basically that live workshop, but it's like a video tutorial series now. And I think that'll be better because a lot of people are like, well, yeah, I can't make it, you know, this Saturday, blah, blah, blah. So now they can just go online and view it at their leisure. But that's how it started.
Okay, cool. Yeah, so I'll when I post the video, I'll put a link to those to your videos, your workshop videos.
Okay, yeah.
I think they're really cool. I like the idea how you're starting from like ground zero. I mean, maybe even lower than ground zero. You're basically saying, this is the bottom, this is the basement, and I'm going to walk you up the stairs and up the levels. And I kind of like how you're doing that.
Yeah, that's why I call it the tutorial before your tutorial, because when I was looking into the other tutorials, I'm like, well, you need some background, like, you know, before you can get into these tutorials to get the most out of them. So I said, well, this is kind of like a primer or something. You can like get your background information first, and then I'll avoid a lot of like the heavy math stuff that makes it confusing, and then just for clarity. So
right. So we kind of talked this before we started the video. So I'm getting everybody, business people, robotics people, programmers. I think Mark Cuban has been talking about it for over a year now. Automation, machine learning, AI, robotics, and sometimes they talk very general, but also it gets kind of confusing because it's like, data, the data lakes and whatever behind the scenes, the data and stuff, data management, all that kind of stuff. It seems like, at least to me, there's a little confusion sometimes. And they say robotics when they maybe mean bots on the internet. And they got AI and you got AI. And then there's like different types of AI, general AI and specific AI for, the subject. And I know this is a really big, broad question, but can you kind of, in your terms, maybe try to explain some of the differences and trying to help clear up some of the differences between automation, AI, machine learning, robotics, kind of clarify a little bit about the confusion going on, I think?
actually, yeah, it's still a lot of confusion for people who actually are involved in it, especially myself, because like, there's same thing, because I work in, development, IT type work. And even then, like, you got to separate the buzzwords from the actual, like the marketing terms from the actual technology. So, because like you can run into some like new thing, you say, oh, this is a new thing. You find out it's like somebody just renamed something from 10 years ago. And now it's
Right.
that. But as far as like the way I kind of categorize it is artificial intelligence. I define that as, well, that's like an umbrella term. So like you said, it covers a wide range of things. So, but the goal is kind of the same. So I think of like kind of the high level goal. So even though we're talking about artificial intelligence, and there's many different aspects to that, or branches in computer science dealing with that, I guess the overall goal is getting like computers, things we use every day now, to have the cognitive abilities of humans. So just think of any kind of thing like a person might do. We want to be able to like program a computer to do that. So like you mentioned automation. So like, let's say we're in some manufacturing plant. I mean, we already have like, automation robots that can do types of things, but actually this was years ago. I went on a tour of a robot company, I think local company called Fanuc, I believe that's what it was. And this was like 10 or 15 years ago. And they were showing like, well, they do the robot arms, for manufacturing and stuff. So I'm in Detroit, so the auto industry is the main thing here. So they had a robot arm that it had like a big bin of connecting rods, the parts that goes to the piston and the camshaft and things like that. So their robot camera was able to look in there and put the hand in there and correctly position the gripper inside the whole of the connecting rod and pick it up and then put it on a conveyor belt and align it, the correct orientation on the conveyor belt. So that's something a human can do. We can, and we do it probably without even thinking about it. We can just say, hey, pick up that connecting rod and put it on the conveyor belt in this orientation. So that was back then. So that's kind of a form of AI because it's a computer doing something, a cognitive task that a human can do. So that branch of artificial intelligence is robotics. But within that, even within robotics, it still like touches the other branches. So for example, so all the phones now, like what's it, Google Assistant and Siri and all that stuff, they use like natural language processing. So that's another branch of AI. So we're getting a machine to be able to process language, which is another ability that, humans can do. And then data science, that kind of branches off. That kind of is a different kind of goal, but it's using some of the techniques that are used in artificial intelligence. So yeah, like you mentioned, robotics, it can use all the different other branches too. But my tutorials and things I've been focusing on are just like machine learning, which is getting computers to have the learning abilities of humans. So that kind of cognitive skill or ability. So I don't know if that clarifies it a little, or it's kind of a broad.
Yeah, I mean, we probably don't have people can watch your classes online for more of the details. Because the reason why this topic is really interesting to me is because a lot of people right now are looking at how they can integrate machine learning into robotics, because robots are really pretty stupid. Now you can program them to do stuff, but what they're trying to cut corners in some sense. They're trying not to spend months and years trying to program a robot to do something. They're trying to get machine learning and using machine learning to teach the robot stuff. So I'm not saying, I know it's possible, but do you have any feelings or ideas behind that? Maybe some examples, because I think that this is a topic it's going to be becoming more and more popular, and more questions and more people are going to be looking into this. So how can, in your mind, how can machine learning best help robotics people develop smarter robots? I guess is my question. Or is that too big of a question?
Well, actually, when I was doing the intelligent ground vehicle competition, like the college competition, that was our goal. We were trying to get this robot car or vehicle to navigate like the obstacle course and things like that. I mean, now they have the cars, Teslas and things that do that already. But there were people using different approaches. So one of ours, we did try to use like a neural network and machine learning to train it to navigate. That was one team, we tried that approach. So as far as like getting started with like your robots to do that, there's many like platforms that can incorporate that. But what I usually do is I start kind of online in the cloud first using the tools, like there's like Google Collaboratory. That's one. You can do like machine learning type things and data science type things. There's a couple other ones. I forget the name of the other one, but there's a couple other ones. Google's the main one I use, but you can just train models to basically on the data. So for example, one cool ability you might want your robot to do is to perceive its environment with a camera. So in that case, you might have a neural network, like a convolutional neural network or something like that, to detect objects in the scene. So maybe you want to detect, an obstacle in front, or you don't want it to hit a person, or maybe you want it to target a human being or something like that if you're in the military. So that's one aspect of it. You can do computer vision to add that to your robot. Now, the other one is one thing that robots need is, if they're to be really practical, they have to be able to navigate in an environment, like a physical environment. And that's really difficult because in the simplest case, you have like static objects and things, but think of something like an airport or something. Because I remember a while back, there was someone, they were trying to do like a robot baggage handler or something like that, or bus, or, bus hopper, not bus hop, but
Right.
I forget the term, but the person that carries your luggage in the airport. So think about that environment. There's like people, there's a crowd has to navigate to its goal, but in the short term, it has to avoid like immediate obstacles and things like that. So in that case, you might be using some type of path planning algorithm or things like that. And a lot of those kind of things are more like kind of mathematical. They use like kind of mathematical structure. So um, there may be some machine learning approaches to that, but so
So
just
can
it's kind of like a piece build for each type of thing you want. You have to like pick the type of one of the topics from AI to however whatever you want your robot to do. But
right.
like robots is a general thing. They could be doing all like from vehicles to serving in restaurants and things like that. So depending on what you want to do.
So I was trying to come up with some examples on my own, and I was thinking maybe something as simple as you have. I know Samsung and some other companies are developing robots with grippers
Hmm.
to do basic tasks. So I was thinking, how can maybe machine learning help a robot in that? So if you could train a robot, what is a cup or what is a dish, uh, and then so that it knows when it looks at it using whatever vision sensor it has, it knows, okay, we might even be able to make it sophisticated enough so it knows if the dish is clean or dirty, maybe,
Hmm.
and then it knows to be able to pick that up and then put it in like in a dishwasher to clean up. Uh, that's something I was thinking about maybe, and then maybe like something like let's say you train the robot to go around pick up items off the floor. So if it picks up a piece of clothing, it goes, oh, this is a piece of clothing, so I take it maybe to a hamper or to dirty clothes uh, basket,
Right.
or I take it to to a drawer or whatever someplace. So I was thinking maybe uh, machine learning could help in that area to train the robot to do simple tasks like just picking up, maybe like I said, knowing what is a dish, what is a cup, and how to put it in. Whether it's right side up and how to put it into the dishwasher, and maybe even be able to train it in if the clothes are on the floor, and if you detect that they're maybe dirty clothes or used clothes, that
Mhm.
it can take it to the washing machine and put it in the washing machine. So those are some of the kind of ideas I'm thinking in my head, because I think a lot of people are thinking, how can we train robots to do basic simple tasks like in the home or in the business?
Yeah. So yeah, the one thing when I'm like analyzing like solutions, like you just mentioned, for like maybe something that picks up dirty clothes and puts them in a laundry chute or something like that. As humans, it's so easy for us to just like see that task and like understand how it's done. But then when you try to actually program it and get a computer, you like actually realize you have to learn how to like think about, well, how am I actually doing this? Because we just take it for granted, like, oh, you do this, 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 and then this step and that step. But when you try to start trying to get a computer or machine to do that, then you realize you have to try to analyze, well, how am I doing it? How's my brain working to do that? So, like you said, that involves like many different things. For example, that involves like computer vision to detect things. And then you can also, like you said, train it for behaviors. So that would be like a kind of different type of thing. So once you get it to recognize objects, you'd have to train like some neural network to recognize objects. Then you might try to train it for the behaviors you want. So then you might say, okay, now that I recognize like, I don't know, some socks on the floor, um, what are the steps that a computer has to do to pick it up? And then it has to know like where it is in the room. So it knows like, where do I take it? So all these things like come to light once you're trying actually dig deep into trying to get a computer to solve it. So And that's the job of people who work in AI and artificial intelligence or robotics, figuring those things out. But yeah, so you could use, yeah. So like traditionally, like that's what we would do. We like figure out all these different like, algorithms to get the computer to do make these different decisions. But now using like the neural networks and things like that and machine learning, you can actually just, as long as you have the data, um, you can train it to associate certain inputs with certain outputs. Like, okay, when you see a sock, move towards the sock, you can train it to do that, you know, target that with the gripper and then like find your way back. So you may have to like piecemeal some different technologies together. You might not get it all in one component. But then that brings up, that reminds me of another, you were mentioning like ways people can get started. I don't know if you're familiar with, it's an open source project called Donkey Car.
Yes, yes, yes.
Yeah, so that's, there's a local Donkey Car meetup group where I live in Detroit, Michigan. And we meet sometimes, and that's a good way that I see people getting started in it. Because you just get an RC car, you get a Raspberry Pi, and then they have the software you can download. So, and that's what you were talking about. We're training a car to go around a track. And just like using that, you learn a lot about first application, applying it. And then if you want to dig deeper, you can go into actual code because it's open source code and see how it works. But mainly how that works is we just like, well, I'll explain the process since it's kind of related to what you were saying. So we have this like RC car, we have a track, RC car has a camera on it. So we wanted to learn how to go around that track without going outside the lines and things like that. So the way this donkey car project works is we manually drive it around the track. So a human is actually driving it and it's collecting the camera data and the joystick position data. So it'll take a picture of the track and then it'll record your throttle and steering
Okay, okay, yeah.
values. And it'll record those as one frame. So for every frame of image, you have like a recording of the track and a recording of your throttle and steering commands that you gave it. So with this data, you have, if you drive it correctly, if you're driving the car correctly, you have correct data on how to drive this car around the track. You have, if I see this in the camera, a certain like image of the track, then I should use these throttle and steering commands to stay on the track. So if that data is good, we train the neural network in that project and it learns if your data is good and your model's good, it'll be able to do that autonomously. So once you train it and create your model that's learned from that data, then it'll go around the track by itself. And it's kind of creepy because one time I was training my model or training the car, and I was just like, I could, I'm not really an RC person, so I can't drive one really good. So I was just driving kind of crazy and erratically. And then I trained it on that data, and it was like creepy how when it was on its own, like the robotic mode, autonomous mode, it was driving just like me. It's like it was just like driving, like making my same mistakes and things like that. So
That's interesting. I know. So AWS has a racing league,
yep.
and it's very similar. They even have cars. They even have online virtual racing cars and models that you can work on. Yep. And it's probably oversimplification, but I think I've watched the video on how they do it, and you basically just have the robot go around the track, and it fails lots of times, but it keeps getting reinforcement. So it knows it gets like positive reinforcement when it's driving down the center dash line. And then when it deviates, it drives off one side or the other, and it crosses the yellow line, it gets negative reinforcement. So the idea that after hundreds and thousands of attempts to go around a track, it'll basically learn to stay, to drive on the center line. And then I think you increase and decrease the speed and other things. And basically it's probably oversimplification, but it's basically positive, negative reinforcement. And it just trains itself to go around the track. So very similar to what you're talking about with the donkey car. Yeah.
Right. If I'm correct, I think AWS, because I remember when that came out, because they had like a pre-order before it was actually available. And I think they did consult with the Donkey Car people, and like I think it's kind of their version of that project.
Right.
Um, and but yeah, like you said, but they chose a different approach. They were choosing like well, there's different types of ways you can train these like neural network models and things. So yeah, they were using reinforcement learning, whereas I believe the Donkey Car were using like a supervised learning. So there's like the different types.
Oh, okay, that's right. That's right. Right. Right.
Oh yeah, they're using but they're trying to achieve the same goal. So yeah, it would be interesting to have a race between the AWS one and the Donkey Car. Well, a well-trained Donkey Car, because mine could never train correctly.
Yeah,
And
yeah.
see
Put
the
it on.
difference.
Have a neutral track and
Right.
have the Donkey Car guys train, and then have the AWS racers train on their tracks, and
Yeah.
then come up with a new track that nobody has seen,
Right.
and then see how well the different training methods are in getting the cars to drive around the tracks without
Yeah, that'd be a
driving
cool
off.
competition and have AWS put up the reward money.
Yeah,
Jeff Bezos himself.
yeah. So is okay. Donkey Car is a good example. I'm glad you brought that up. Is there any robot platform? So if somebody, let's say you got a roboticist that knows about robotics, or you got an AI machine learning person who knows how to program. Is there other examples other than Donkey Car of a good entry level or beginning level robotics platform for people to start getting into AI?
I mean, now there are. I mean, there's like, oh man, dozens. Because I don't know if you remember way back in the day, the best one I've ever seen was the Sony Aibo dog. I don't know if you remember that one. That was like, I don't know, that was like the holy grail of engineering and robot design to me. But I guess it didn't work out commercially for them. But
Right.
I think they brought it back in another form. But yeah, there's nothing really like that. But there's plenty of other platforms now available, and mainly a lot of them are there's a lot of like the humanoid ones. So like if you go to any like I don't know robot online, I usually go to Robot Shop. It's like a Canadian company. I don't know if you're probably familiar with them.
Mm-hmm.
They have a lot of platforms there. So there was one I used. It was called Robo Builder. I think they've kind of changed it now what they offer, but that was just the basic kind of hardware platform. You can remote control it. You can program it and download that program like a simple program. But as far as AI, you'd have to bring in some other kind of thing. So there's lots of like hardware platforms, but a few kind of combine both. There was actually a couple of Kickstarter projects I was supporting. Um, but I like building stuff from scratch for myself. So a lot of the projects I've been doing, I've been just kind of like building my own from scratch because I like, building the hardware and then trying to do the software. But I mean, if you go onto like any of those like robot online stores and stuff, you'll see lots of platforms like for AI. There's many more now than there were,
Yeah.
before.
So some of the examples that I've seen, they seem to be very popular. Is the AWS, the Amazon has their robot that you can buy, robot car, RC car,
Right,
with cameras, and I think it has an Intel CPU processor
right,
board on there. Uh, NVIDIA has the same has a platform that the Jetson, uh,
right,
which has vision, which is designed with TensorFlow and what Keras, TensorFlow and Keras and all that stuff.
right. And that one you can actually I've seen some Donkey Car people use those on there instead of the Raspberry Pi. So yeah, that's the cool like kind of brain part that you can add to any hardware you want. So that's why I like some of these platforms. They're like the hardware. They don't necessarily have any AI ability, but you can combine the two and then get like better results that way. And yeah, so those are the main ones I'm thinking of right now.
So do you mainly use the Raspberry Pi for your car?
Yeah, I have recently. It has its limitations. Like I mean, as far as like performance wise, but I don't have like a really big budget to keep buying because I can go bankrupt just buying like robot hardware. That's where a lot of my money's gone over the
Right.
years. So I try to keep my costs down. So like something like that. But my approach is I want to use like I want to put my brain in the cloud where I have like basically unlimited cheap processing power, and then just use the robot itself as like a kind of dumb client. Basically, it's like, hey, I have the sensors, I can collect all the information, do like the grunt work of, sending this data to the cloud, and then the cloud will, do the decision making, send back the commands for the dumb robot. That's not what I use for the donkey car right now because of the latency issues, but for my future projects, that's how I want to approach it.
So yeah, that was interesting. That was one thing that I thought was pretty cool about your AI machine learning classes is that I heard about the Google platform, but I never used it, and it's good that you're kind of introduced me to the platform because I have been experimenting a little bit with the AWS RoboMaker and AWS, and so now I'm going to get some exposure to the Google platform. Oh, that brings up another topic. Well, we could talk about the pros and cons of Google or AWS or what you think is easiest, best to use. But I always get this. So TensorFlow is basically written in C, correct? The underlying stuff is all C, is what I've been told.
Yeah, I believe it.
But now everybody's interacting with it using Python. So I've heard people say, that if you're writing, if you're programming in machine learning AI, you should do C because it less overhead and C is a little faster. But Python, I've also heard, but Python's easier because it's mainly just method calls and API calls. It's set up to be really easy for beginners to learn. So, do you have any opinions or suggestions? Should people write in C or should they write in Python?
Well, that's the cool thing about the TensorFlow project is they provide like many ways you can interact with it. So there's like Python, C. I think there was a Java one also. So I mean, whatever your preferred whatever language you're comfortable with. I use the Python API for it because it seems like there's more like examples and things I can use for it. So that determines a lot in documentation using it that way. And even some like Java, I think originally the language itself was written using C. So it's like it's like, well, if you don't want the benefits of some other language, but I think it depends on which one you're comfortable with. Like, I mean, yeah, everything basically embedded, you could use C to write it, but I like to use something like higher level, not higher level, but not so much. How can I say it? I like these languages that are a little more like abstracted from the hardware so much. But C was like, yeah, back in the day that was like one of the few only choices you had.
Right.
But now there's other options. It's like, and I base it mainly on like what other like libraries and things are available. So like Python, I can find like pretty much any kind of library to do anything I want. So,
right.
Plus I'm like, I don't know. I mean, yeah, originally I was a C programmer way back in the day, but I don't know, I've kind of drifted away from it. But if you work with something like the robot operating system, ROS, yeah, that's all C, C++ kind of stuff.
So yeah, we have there's the same debate with ROS. A lot of the underlying packages and the navigation and everything was written in C.
Yeah.
But now everybody, is saying, but now it's like Python is becoming more and more popular, and it's the same thing with TensorFlow. You have a lot of API calls that you can do in Python, and you have a lot of people writing in Python. So they're writing it's almost like Python's on top. It's like the front end, and then all the stuff going on behind the scenes is all in C. And that sounds like what happens in TensorFlow is kind of similar to what happens in ROS, because everybody's migrating to the to Python, because it seems like everybody coming out of school knows Python.
Right. Yeah.
Python now.
Yeah. And there's like, it just keeps splintering off into more languages, because what's the other one? Well, a lot of data science people, I think they use R, and what's the other, Scala or whatever those other ones are.
Oh yeah, yeah.
I haven't used any of those, but I've met a lot of people who use those.
So if you're not writing stuff from scratch, is pretty much everybody using TensorFlow and what Keras? Did I say that right?
I mean, it's the most popular that I've come across. I mean, yeah, that's the thing with technology. Everybody has their own like pet technology stack they like to use. So, but as far as like popularity, I would say like the Python, Keras one is popular.
Okay. Yeah. So
But
yeah,
there's something coming along like every day, basically, So
right. I think the research I've been doing on the NVIDIA Jetson, it's a lot of TensorFlow with so the Keras is kind of like the Python API calls. So a lot of the NVIDIA stuff is using Python, Keras, and linked into TensorFlow. So that's
a lot of that dictates like what I use. Like, okay, so what, like if I'm trying to use that platform, then it's like, okay, well, I kind of pretty much have to use Python, or I need this type of library. It's only available in Python or C or whatever, so I'll have to use it that way. But I try to stick to one platform just to keep everything consistent, or one language. But
okay, very cool. So have I kind of missed anything? Is there anything that I may be not explain well or confusing, or is there like a topic about AI machine learning? It's usually a lot more than I do. Is there anything that you've seen coming in the future, or is there some relationship between robotics and machine learning that you think would be a great topic to add?
I think the main thing is, I'm trying to think. It's a good question. I guess the main thing I can see now is, like I mentioned, actually there was another company there, I can't remember the name, but they're using that approach with, actually I had posted it a while back. They're using the same approach where you have your robot, your physical robot, and it learns, the main brain is in the cloud. I do not remember that company. Well, I'll find it. But,
yeah, there's a
so
lot of
a lot of
companies.
that, yeah. So, and there's, I think, there was an X Prize competition too about avatars, where, because everything's going to be connected now, and then I guess 5G is supposed to improve that. So it's kind of driven by that. Like, okay, we're going to reduce this network latency now, so that opens up the possibilities to have like a central, which is actually the holy grail or the goal, as far as I'm concerned. It's like, I mean, hardware is going to get more powerful, but you're still going to be limited as far as like what you can actually put on a physical robot. So some of that will have to be distributed, and there has to be some connectivity, because the one benefit that robots will have over humans, one of the many ones, is that we have this body of knowledge as humans, but everybody has to learn it from start all over again. So like, a kid kid born today, they have to learn all the mathematics, history, physics, or whatever. Whereas a robot, as soon as it's manufactured, it'll have access to all the knowledge instantly, and then it can build on that. So that's where kind of this like cloud mind or cloud robotics kind of thing comes in. I see that as being more. But the thing I still kind of, well, when I was little, like robotics, I used to watch shows like, the Jetsons and Lost in Space and that. So when I was little, I always thought like computers would be in the form of robots, and then everybody would have a robot in their home. But it turned out everybody would have a desktop or a laptop. That was the first thing people used. So like, yeah, no, yeah, in a phone. So I never predicted it that way. So I think I'm still like putting a lot of faith in robots in every home, but I'm wondering, like, there's always something you can't really predict. It's just based on what the most practical, useful thing is for people in general. So if robots are the thing that's going to be the form of AI takes, then that's the form it'll take. But like I said, so I'm kind of biased towards the robots and connected to a cloud mine, but it doesn't necessarily have to be a robot. It can just be like Siri or something like that, or Google Assistant or something like that, because that's used a lot of like some of the most advanced AI, like available. So it's not necessarily a robot.
Yeah, I think a lot of people are trying to figure out how to leverage all the money that Google's putting in AI and AWS, Amazon's putting in AWS, RoboMaker, and some other stuff that Amazon's doing. So I think a lot of people in the robotics field are trying to figure out how to leverage all that money, all that, because Amazon and Google are spending billions. And it's almost like there's pros and cons, I guess, because for like Alexa or Google Assist. So what is better, having a mobile Google Assist or a mobile Alexa platform driving around, following you around all day? Or does a phone work better? But I kind of think, to me, I don't know how you feel, but I kind of think everything is going to kind of merge together, because I think there's benefits to the phone and the apps. There's benefits to having a mobile robot, and there's benefits to having like Alexa or Google Assist. But I think it's kind of like a marriage of the technologies together. So I could, at least me, from my point of view, I could see in the future you'll have some kind of mobile, basically like almost like an informational kiosk kind of thing following you around. I don't know it, because to me, there's all kinds of sensors and all kinds of stuff that they can add on to a phone and make it really big. But instead of having to carry around a big, huge device, you have a walking or mobile robot assistant butler. I mean, I've seen iRobot and some other science fiction novels and movies where everybody has a robotic assistant, robotic butler. I definitely see that is possibly not the near future, but definitely something I think everybody's thinking about. And it's more like you said, I'm kind of biased more to robotics, and I think that there's definitely, I at least see a robotic assistant in the future for everybody.
Right. And I think the common thread is in the background, whether it's like hardware based or something like, software based, it's still going to be using like whatever the latest AI, discoveries or researchers in the background that's going to be driving it all. So the AI will stay the same as far as like software wise, but how it's, how it manifests itself, whether in a physical robot or some kind of like software ability, that'll be different. But I think, oh yeah, now I remember the company. Yeah, the company that was doing, it's called Cloud Robots, believe it or not. So yeah, they're trying to do like the cloud mine thing for robots to do similar things like you're saying, like assistants and things like that. I was trying to think, there was some other examples of that, but that's the main one I can think of right now.
So this may be another oversimplification on my part. So when a lot of people think AI and machine learning, they're thinking in pictures. So the robot has a camera, and the robot's been trained using pictures to identify objects. But can't you do the same thing with a sensory input? So let's think of something really simple as the temperature. So the robot reads the temperature inside the home and knows what, maybe this is oversimplification, but it uses some sort of sensory data input. So if it knows if it's raining outside or the temperature's outside, it can inform the human wear your umbrella, take an umbrella today or wear a coat today. I mean, because people are different. Some people like the rain doesn't bother them or snow doesn't bother them or cold doesn't bother them, but heat does or something.
Right.
So this is probably an oversimplification, but you can't use machine learning and AI with sensor data, just not picture data. And I think you kind of mentioned that with the donkey car.
Right.
Right.
Yeah. Well, actually, yeah, that brings me to the other point. You were all talking about like how it's going to be used. So right now, that's kind of like the buzzword. Everybody's saying, "Oh, my product has AI in it." I guess you might be talking similar to something like that Nest thermostat.
Yeah.
It's kind of similar. So I don't know what actually they're using inside, but like you said, they can AI technology and algorithms can be used in any type of product or thing like that. Um, so I think, yeah, that's probably the more likely route that AI will be used as a commodity in products, and it'll be specific for each product. Like like the Nest, it doesn't necessarily computer vision, so it won't use that component of AI. It'll use something else, like but it'll still be some kind of machine learning or something like that. So that's the most likely scenario, I guess. And then we'll also have robots too, I guess.
Right. I mean, of course, we can't come up with all the cool ideas. Somebody's going to come up with a cool idea that nobody else has thought of, and basically write that killer app or that killer automation process that'll save people all kinds of time and money and so on.
Yeah, and I think, oh, you were talking about before about like a robot, carrying around with you and being with you all the time. I was judging a competition in Korea. It was called the Robot Olympiad, um, and then they had some like talks also, like a little conference there. So one of the professors there, the like intelligent systems professor there, he did a talk on ubiquitous robots. This was way back like 2006 or 5 or something like that. So he was
Well, that's
talking
a
about,
term I haven't heard in a while.
yeah, he was talking about that way back then. He basically was saying it's the same thing wherever you go. Like when you go into your car, your robot assistant is like downloaded into that. And then you go to work or something like that, and then you log into your computer at work or something, and then it's there helping you there. So it's like wherever you go, it's like kind of connected and follows you around. So I guess our smartphones kind of do that now, but he took it one step further. Like it's just I don't know whatever happened to that research, but
That's an interesting idea. That's an interesting idea. So, okay, so let me brainstorm real quick because that just kind of triggered lots of thoughts. So you have a cloud AI that's learns your behaviors, learns your speech patterns, your behaviors, your likes, your dislikes, and it follows you around. So when you're at home, you have like a humanoid robot wheeled or a walking robot, and it has that cloud AI,
right,
access to that cloud AI, and it's interacting you through the cloud AI, but it's a physical robot in your home. Then when you leave your home, the robot doesn't have to actually follow you.
right,
If you get into your Tesla car of the future, the AI will have the AI of the car will basically be the same AI. It's like, uh, oh, Marvel, Iron Man, Jarvis.
right. Yeah, exactly.
Yeah. And Jarvis, sorry, I was like, so you go into your Tesla car and you're driving around, and the AI is cloud AI, is connected, and it's the same AI as at home, but it's just a different form, physical form. You go into work, and then maybe your computer, you log onto your computer or your laptop at work, and you connect to the cloud, and your AI assistant's there in the background to help you. And if you need, let's say you need an extra arm or extra hand or some help, a robot at work that's like in a storeroom somewhere, in a common room somewhere, gets activated and now has access to your AI. So it knows you, knows your likes, dislikes, knows what all that stuff, and it helps you at work when you need it. I kind of like that idea. That's a kind of cool idea.
Yeah, and I think I'll have to look it up and then I'll send you the link if I can find his paper or anything. But and I don't even think back then we had like cloud technologies as popular as they are now. I don't even know if we had any back then. There may have been, but
Right.
so I'm not sure what his like vehicle is for distributing it to all these different locations, but I can't recall that. But now it's an easy thing. Like that's the thing. Like things that used to like take me like hours to do like years and years ago, it's like, oh, there's something already built. I can do that in like 5 seconds. I don't. I've spent less time like trying to like reinvent the wheel and things like that. So
I like that. I'm glad you brought that up because it's everybody will have basically Jarvis, if I'm
right,
saying it right, from Iron Man, Tony
yeah. So
Stark's.
that might have been 2006 or so. Yeah, because
Yeah.
I went to it was at Keist University
Oh yeah, that's
in
a big company. Yeah, that's a.
yeah, that's
Have you
like
seen
their the
the?
MIT in
Yeah,
South Korea. Yeah, South Korea.
yeah. They developed their big huge humanoid robot won the DARPA robotics challenge.
Okay, yeah, yep. Yeah, because they were doing like the robot Olympiad for kids and college students and things like that from all over the world. So
Very cool.
I even met I even met a college team from Mexico there in Korea. So that was years ago. So yeah, I'll find that professor's paper and like that kind of
Yeah,
sums
and yeah, send me the link and then I'll put that in the description area so people can check that out. Okay, very cool. Uh, you've been very generous with your time. I don't want to keep you
Oh, okay. No, that's all. Yeah. Well,
forever.
Saturday I'm a little more open, but yeah.
Yeah, I don't want to keep
During
you
the week,
forever.
work keeps me busy.
Yeah, I think I think you've done a very good job of answering my questions, at least
Okay, cool.
explaining kind of your point of view because you have a lot more knowledge in this than I do. I do come from we both come from robotics backgrounds, but you definitely have more knowledge and understanding of machine learning and AI. So
Yeah, I
uh,
guess it mainly comes with just working on projects and things like that. So, because like I said, in when I was in college, we had like basically had to like invent things ourselves. So, and we didn't have the tools we had now, but I mean, the basics are the same. So,
very cool. So just kind of wrapping up, is there so if you had any think any more topics or ideas to bring up, also, so how many? So you what is it 5 videos now in your AI machine learning?
yeah, I'll be posting the fifth one hopefully today, later today. I have to do some more editing with it.
Okay.
And then I have to go over, let's see. Oh, yeah. So I have to do another one about how you train the neural networks. Then I'm going to get into the actual like project, which is just it's called the exclusive OR project. It's kind of like the Hello World for AI. So that might take 2 or 3. So maybe like 3 or 4 more videos to go. So I try to do it every week, but sometimes it doesn't work out that way. Sometimes they're
No,
a little
so no,
more
I think they're pretty
time.
cool. Hopefully, more people will watch them.
Right.
Uh,
And I would like once I get the whole series done, I might consider like increasing the production value. So because right now it's just me and but if they get really popular, I can like uh, kind of redo them with more like animation and graphics and things like that because that always helps like when you're learning some complex topics. So I
right.
put as much as I can with the PowerPoint
Okay.
thing.
Very cool. Very cool. So, kind of thank you for your time again.
Oh
Uh,
yeah, thank you for the opportunity to do this. This is great. Yeah, and I
okay.
always love all the toys you have in the background.
Cool.
Now,
Okay.
do you
So,
have like a list of all the toys you have, or do you post
uh,
them?
I'll
I know
show
you
you,
post them on your thing.
there's Snow, my robot back here.
Uh,
It's a social service robot,
I
and
think I
then
remember
I
you
got a
posted
couple of
that.
humanoid robots up there. Uh,
Okay, yeah.
Unfortunately, I would like a lot of people. I don't know if I've gone to a in-person robot conference or event or competition
Mhm.
or maker fair. I think the last one I went to was in March, right before everybody started shutting stuff down. So I think it's been over a year now, almost a year now since I've done anything other than these virtual talks,
Yeah,
conferences.
because I met you at the one at the Henry Ford, right?
Right.
Well, that was like 2 years ago, I guess, right? Yeah.
Almost, yeah, almost 2 years ago now.
So yeah, so hopefully they can do those again because that's a great venue for, like, presenting these things.
But yeah, so I got the Snow, the social service robot. She does have connections to AWS, so she can answer basic text to voice, voice to text. And I got some humanoid robots there in the back. I got a transforming robot. When we start opening things up again, I've got a few robots that I think are pretty good in teaching basics of robotics using either JavaScript or Python. Just reading sensor information like line falling, distance sensors, obstacle avoidance. And a few of the robots are getting pretty cool now. They'll have like something similar to the Arduino or a little bit better. And they'll have a vision camera that does a lot of the AI processing for it.
Oh yeah,
cool.
Yeah, that reminds me.
Yeah. There's some really there's some really cool advanced sensors, camera sensors you can buy nowadays.
Right, I think I've seen that one somewhere.
Yeah, from DF Robot.
Yeah. Oh, okay, that's where it is. Yeah, because I get their mailing list. Okay. Yeah, and a lot of them, Scratch has added like some AI machine learning blocks and stuff. So a lot of like these kind of STEM robots, they integrate with Scratch now. And
Right.
actually, a professor at Lawrence Tech, he just recently did a workshop using Scratch and AI. I think so.
Well, that's interesting
Yeah.
because if they can integrate some basic AI through Scratch, that'd be a great way to teach kids.
I don't know if he was using hardware. It was all like, I guess, the block stuff, but it
Right,
used
right.
the computer's camera.
Yeah, but Scratch is really cool because there's a lot of kids that get introduced to Scratch pretty early.
Mm-hmm.
And if they can incorporate some basic AI and machine learning into Scratch so that kids can learn basic AI and machine learning before they have to jump into like Python or something higher level language, that'd be really cool. Yeah.
Yeah, and I was using it for my platform because I build my own. I was trying to use it in Scratch. It almost worked because the way Scratch works, it was kind of open source, so you can whatever platform you have, you can kind of customize it for that platform. It's just they had some bug that didn't work on a particular Linux or something like that, so I couldn't get it to work. But once they fix that bug, I'll have Scratch available too for it.
Yeah, that would be another cool video series.
Yeah.
You could teach entry level AI machine learning using Scratch.
Right.
And then
yeah, let me put that on my notes. That's another link I sent.
Cool. So very cool. So I think we'll kind of stop
okay, yeah.
And then of course we could always do another one and another one and another one, just depending on if new topics and stuff come up. So thanks everybody for watching. Thanks for the time that you shared with us and everything and the information.
Oh yeah, thank you for the platform to talk about this stuff. I love talking about it.
I hope to see everybody in my next video. So goodbye for now. See you later.